Welcome, fellow chemists, to the promised ketone and aldehyde nomenclature video. If you have a topic for a video I have yet to announce, please suggest it. Like before, I will use conventional IUPAC names for these molecules, but I must mention two common names. This is an introduction to simple ketones and aldehydes rather than an exhaustive look. I will use rules and conventions established in previous videos, so if needed, check the playlist in the description. Ketones are pretty easy to identify because you'll see a carbonyl where carbon double bonds to oxygen. In a ketone, that carbon double bonds to two other carbons. If one of those carbons is anything else, it's not a ketone. Ketones are a functional group and get the suffix "-one in the name. With many substituents in functional groups, there is a ranking for prioritizing them within IUPAC nomenclature. Refer to this list in order to choose which substituent or group to number first. Ketones have the highest priority of anything I've covered so far. Given that, try to name the molecule on the screen. Of course, the ketone suffix "-one goes at the end. The parent is 3 carbons or propane. The ketone is at position 2. Putting this together, we get propane-2-one. The E in propane was removed to avoid consecutive vowels in the final name. No one calls it this, though, because this is acetone. Now for some examples, and when the structure appears, feel free to pause the video and name it before I do. The parent is 6 carbons long, or hexane. There's a chlorine and a ketone. We number from the right to give the ketone the smallest number possible, 3, and the chlorine gets a 5. Remove the E from hexane and we get 5-chlorohexane-3-one. The parent is 5 carbons long, or pentane. There is a chlorine again, and now 2 ketones, so we need the prefix di. We squeeze this one before the functional group. Number from the left, and the ketones are positions 2 and 3. While chlorine gets a 1. The full name is 1-chloropentane-2,3-dione. The E in pentane stays because the next letter is the D in di. This molecule contains 4 carbons, bute, and 2 functional groups. The double bond is an ene, and we have a ketone still. Numbering from the right to prioritize the ketone, it gets a 2 and the double bond a 3. The final name is bute-3-ene-2-one. Aldehydes look similar to ketones, but one of the carbons gets replaced by a hydrogen. If we replace the other carbon with something else, we have a formal group. Remember that term. Aldehydes are also a functional group and get the suffix -al in the name. The priority of the aldehyde is actually greater than that of the ketone. On chains, since they must be on the end, the aldehyde carbon is position 1 and does not need to be specifically numbered. With that information, name the aldehyde on the screen. There is only 1 carbon, so methane, and put the suffix -al at the end. Remove that E and it's named methanal. But no one calls it this. This is formaldehyde. Now for some more practice, so try to name the molecules before I do. The parent is 5 carbons, or pentane. There are 2 iodines, so we need the numerical prefix di, and of course the aldehyde. Numbering from the aldehyde, the iodines are both on position 3, and we get the name 3,3-diiodopentanal. The parent is 6 carbons, or hex. Bromine is a substituent. We have the triple bond ine and the aldehyde at the end. Numbering from the aldehyde, the bromine is position 3 and the triple bond position 5. Putting everything together, we get 3-bromohex-5-inal. We have a 7 carbon parent heptane with aldehyde groups on each end. Don't forget the prefix di, and the full name will be heptane-dial. As Beyonce once said, if you like it, then you better put it on a ring. If the oxygen is double bonded directly with a carbon on a ring, we have a ketone. It is named exactly as you would expect, cyclopentan for the 5 carbon ring and -one for the ketone itself. This cannot happen with an aldehyde, so the oxygen double bonds to a carbon which then bonds to the ring. Naming aldehydes is just as easy, right? Cyclopentanal makes sense? But no. How about cyclopentanaldehyde? No again. Aldehyde groups bonded to rings in this manner are called carbaldehyde, so the name is cyclopentane carbaldehyde. Let's try some practice with aldehydes on rings. The more complicated bit is not adding substituents, because add a bromine to the cyclopentane and we name it with the knowledge we just gained. The higher priority carbaldehyde is position 1, so bromine, or bromo, is position 3. The complicated bit is knowing the ring is now a substituent on the chain containing a functional group, so it becomes 3-bromocyclopentyl. The ring is on the second carbon of the mini-chain, but the 2-carbon chain in aldehyde is not sensibly named ethanal. Instead, it is called acetaldehyde because convention. Sorry students, get used to naming conventions being used all of the time except when they're not. Now the same substituent is on the third carbon of the chain. The aldehyde portion is finally, predictably, and sensibly named propanal. I'm sure you can take it from here. In summary, aldehydes and ketones are functional groups, with the aldehydes having the highest priority of anything we have looked at so far. On simple, straight chains, ketones are internal and the locations numbered, while aldehydes are terminal and are not numbered. On rings, the ketone is part of the ring itself, and the aldehyde is part of a carbaldehyde group. Both would be numbered 1 if other substituents were present. If the ketone or aldehyde is on a chain that attaches to the ring will be a substituent. Ketones are named normally, as are 3-carbon or larger aldehydes. However, the 2-carbon aldehyde is called acetaldehyde. Thank you very much for watching. If you enjoyed this video, please like and subscribe as I have more in development, with the next video being a special announcement about the future of the channel. In the meantime, here are previous videos involving reactions that produce ketones and aldehydes.